Hi, good day, everyone. Welcome to Encyclopedia Book and welcome to the Docker series that we have been discussing from weeks. And in this session, we are going to discuss about the agenda that I have put on the screen. So, so far we have been discussing about the single container only. Whenever we have, discussed about Docker, we always spoke about single container only. And in this session, we will try to explore the ends and bends of the uh, you know multi-container environment where we have multiple container in place, and those containers try to talk to each other via some means. And what are those means and how multiple container can talk to each other, we are gonna take a look into in this session. So at the very first, I have just mentioned like what is buildx and buildkit. So we will also uh, take a look into it, like what these things are. But this is something which was left over in the last session or the previous session, so we'll just quickly take a glance on this, and then after we are going to see container communication, and then we will see how we can persist data in container. Basically these questions, whatever questions I have put in on the screen actually, so this question are pretty much inclined towards understanding the same thing, that is the multi-container communication. So let's get started with today's agenda. So first of all, uh, let's take a look into like what is buildx and buildkit. So if you have noticed, I mean, in the previous session we had discussed the architecture of Docker, right? So basically, Docker is a client server architecture. It follows. So it has three components. So one is the very first is the client side of the Docker, and then we have engine side, or you say server side, or host, whatever you want to name it. I mean, and then the registry. So we have already discussed all these things, but uh, we have also seen like in the client side there are three main things, using which we can talk to Docker host, and which will having the Docker daemons running in that particular server or host wherever it has hosted, be it your cloud or in your local system. So we have Docker run, and then we have something called Docker build here, right? This is also one of the client utility, or you say component of Docker, and then we have Docker compose, right? So Docker build communicates with Docker host, and then your Docker run communicates with Docker host. Compose talks to your Docker host, right? We have already seen that. Now in Docker host, there are multiple daemons running, right? So we have Docker D, right? This is a daemon process. This daemon always used to talk to your Docker run component of the client side. Similarly, we have a build X component, at the client side, which will talk to build kit here. Like we have Docker D here, right, which will talk to your Docker run. Similarly, we have build kit, which will always talk to your Docker build commands, which is being on the component that we have at client side for that is build X. So basically, that is what the build kit and build X is all about. It will just Docker build command will be handled by the build kit at the host side or the server side where a Docker engine is installed. And excuse me, sorry, excuse me, sorry. Docker build will be taken care by buildx. So that is what the pretty much of the business of Docker build and Docker X. And at the very technical level, if you want to understand, we already know like Docker containers are the processes, right? So wherever we are talking, we are always talking about processes, right? Operating system processes, be it your host system or be it, wherever you have Docker engine installed, server installed basically, and it will launch processes. So be it your daemon process or your build kit. So yeah, that's what the buildx and build kit. So let me move on to next thing that we have to discuss, like the container. How does container shares data? So before we get into it, okay, let me just jot down here because it like I don't feel contented until I jot it down or wave my fingers in hand while talking. Just kidding. So let's get started. We have container communication, right? Container communication. So see, we have something called IPC. So when I say IPC, it's not Indian Penal Code. It's inter-process communication in the technical terms. So don't take it otherwise. So it's a inter-process communication here, right? So again, as I told you, if you remember in the beginning of the sessions, like if you want to, get a good grasp on the Docker concept or any concept, which is related to pretty much, down the line with I mean, pretty much inclined with the operating systems concept or, something like shell or shell scripting stuff. Something, at the between, I mean, at the low level, not exactly low level, we can say, I mean, it's a high level only at the system level. So you need to have a good case of operating system. And in operating system, we have a concept called IPC, inter-process communication. And that inter-process communication means what? We have processes, multiple processes, right? So when we want these processes to, communicate with each other, that's where the inter-process, concept kicks in. And it's pretty much the same thing that you know we are trying to understand in the context of Docker. So here we have context switching, right? In processes, between processes, there are context switching. Processes will have PCBs, process control block. All those things are applicable one way or another way to Docker also. I mean Docker container also, because at the end of the day, these are also processes, right? So this is what I mean, inter-process communication. I just wanted to talk about this a bit because it will help you to understand Docker communication in a more, detailed manner. And then there is something called, the concept of your, if you just give me a moment. So if you talk about objects again, see, I haven't started talking about the container communication. I'm just only talking about the operating system stuff, the processes. I'm just talking about the IPC, inter-process communication. Why I'm discussing all those things? Because if you know, or if you first understand these processes, or go and do some research through this, I mean, inter-process communication, and then you come to the Docker container communication, it will be very much, easy stuff for you to understand. So that's why I'm just giving all those illustrations so that it will be easy for you to understand. If you're already aware of inter-process communication, then the things will be pretty much, easy for you to understand. So this is one concept, and then we have another concept called, if in programming or object-oriented programming, we create objects, right? So we create object one, and then we create object two, and then we create object three, right? So see, these objects will have data members, right? Data members means variables or member variables, whatever you want to say. And then this object will also have member function. And member function will always create a stack in the memory. All those concepts you are aware of. So see, the data members means the variables you create, template, class template, whatever variables you declare, that's the data members, right? So let's say if you have A, B, C, three variables in your template, then three variables, memory will be created for these three variables when you create object one using new keyword. And then if you create object two using new keyword, if you create object three using new keyword, for all these three objects, A, B, C, three variables will be created here, right? But now these are the instance variables, and we have a scope called instance context, right? Instance scope. We are not going to discuss all those things in detail because this is again something related to Java and ops related concept. But what I want to discuss here is static scope. So static scope means when you declare static variable, right? Let's say in your class template, you have created static scope D, right? So for that D, memory will be allocated here. For that D, memory will be allocated here. For that D, memory will be allocated here. Is that so? No, this is not right. So since D is a static member, so static member will always have common memory allocated, D. And these all instances will access this D, right? So you see this static is increasing the shareability, right? So these object will have, a contest for accessing this race condition. But again, I won't go into it. But all I'm trying to say, this static variable will have a common memory allocated to it, one single memory, not different memory. So see, they are trying to share the data. So D will be shared to this, D will be shared to this object, D will be shared to this object. So it's a pretty much same thing, kind of thing happen when we talk about container. So container will also uh, you know can share data. How they can share data, I'm just gonna get into it. But before that, if you have a grasp on this static concept, if you're aware of static variables and static memory, and again, it's a kind of inclination this, topic has towards your containers. So these are the two illustrations I have just shown you before even starting with our the container communication. So two things here. One is container to container communication. Another one is container to host communication. What do we mean by this? See, we have created some file system here. I have created some file here, D, right? So this file, I want container one to access, modify it, and same file I would like to have, persisted, even though this container one is deleted. Similarly, if I have container two, if I, bring this container up, so if I would need to have this container to read the file D, it should be, able to, read this file D, modify this file D, all those, kind of the shareability of this file, how we can achieve, in multiple containers. That is what we are gonna, take a look into it. That is the one thing, like how container shares data. Another thing is like, let's say you have a host system, right? We have discussed already, I mean, this thing many times, like what is host system. So be it is my host system, I mean, be it where your Docker engine is there. So be it my local system or, excuse me, sorry, somewhere in the clouds, wherever, you have installed your Docker uh, engine actually. So you have some file system, some files or some data is there in the host and you want that data to be accessible to the container. So for that, we are going to use how we can achieve that. That is what we are going to take a look into. So this is what pretty much we need to understand first in the interprocess, I mean, the container communication. So as I told you previously, like there is a file system called mount, right? This mount will be used to, attain these two alternatives, whatever I have discussed. Container to container communication, we will use mount. Container, excuse me, sorry, container to host communication, we will use mount. So now this file system mount has uh, two things. I mean, so one is called volume, another one is called bind. So volume is when I want a container to container communication happen. So I can create a volume and that volume let it be shared between these two containers. And if I want container to host communication establishment, so I can create a bind and that bind, I mean, files will be there in the host system. And, from container, you can access those files and, you do the modification of those file systems. Now we know, like, we have a file system mount. So we are going to use that. So first of all, let's take a look into like how we can create container to container communication. For that, we need to create a volume. So to create a volume in Docker, how do we create volumes in Docker? What is volume? Volume is the way, I mean, we can, store data, we can create data. We can persist data using volumes. So the benefit of using volume is even though your container is deleted or your container is stopped, whatever data container has written to this volume will always be persisted and we can access that volume to other container. That is the advantage of container, basically container to container communication. So how do we create volume? So basically the command for creating a volume is docker create docker volume create and volume name, whatever you want to give it here. So now I'm not gonna type it out here. So let me just quickly go to the shell here. Let me pull out my shell. So inside this, I'm gonna create a volume. But before that, let me see if there is already a volume created for this. So it's a pretty simple command. I mean, there is nothing. I mean, you need to mug it up. I mean, nothing like that. Once you start working with this, it will be pretty hand. I mean, easy. Lucid commands. I mean, you can practice this practice these commands once or twice and it will be be I mean it will be pretty much in your fingertips then. So like we have docker image ls, so similarly we have docker volume ls, so this will tell us like this is the current volume that I have. So I want to create a volume now. So for that the command is docker volume create and I would give a name to the volume, uh, volume a, right? So see, volume a has been created. So if I do docker uh, volume and then if I do ls, so this time it will show me the volume. So see, this volume is kind of a drive. If you want to understand, we have cd and drives like you know Microsoft Windows. So similarly this will be a drive only, I mean, but only thing is this drive will be used by the container to persist data and it will be pretty much handy when work with your operating database stuff basically, or when you want to store data, save data. So I have got the volume created here. So how do I attach this volume to, you know, uh, to the container? So for that, there is multiple ways. I mean, one way is like, as I told you, like you have created a volume, you can use mount. So let's start doing it by using mount, and then I'll tell you another way. So we have, how do I create Docker containers? So again, right, it's Docker container, Docker container one. And then I need to tell the interactive shell and then the I have to publish the port support or 8080. Then I need to mount a volume to it. So for volume I have source. I need to tell the source. So source is the volume which I had created. right? And then the target I have to tell. So target, I would say logs, right? So I want my file to be, stored into this folder, logs folder. And then again, I just need to tell which image I want to uh, mount on this container, or, build on this container. So it's M platform application image. So let me hit enter. So okay, it has created container. Superb. If I click ls, so it should have created logs folder here. So you see it has created logs folder. So if I get into this logs folder, you see nothing is there in this logs folder. I'll just come out of it. And then I would say echo and container one, right? And I would say this is container one logs, right? And I want this thing to be written into the a file. So I would give that file a name called containers file dot txt, right? So see, if I want to uh, append data to this file, I'll use this indirection operator, double indirection for the operator, like we have in C out C in C++. And if I want to overwrite the data, I mean, on the top of it, so I just use the single uh, greater than sign or shift operator. It will, write this text into this file. So if I hit enter, let's see what happens. So if I get into the logs now, so it should have created a file, cd logs. So if I do ls, nothing it is showing, it should have shown. If I do ls here, see it has created outside the, at the root of uh, the Linux container. Why did it do that? Because I did not mention the logs directory here. So if I again, run this command, and this time if I mention logs here, and then if I use this, so it will just create a folder into that. So if I do ls, if I do cd logs, it will get into it. If I do ls, you see the file has been created. And if I want to, see what all things this file has, so we have cat command here. So we have to give cat and the name of this file. Yeah, so we were saying inside log we have a file created. So if I have showed you already, like if I do ls, it will show me the file. If I do cat and then this file name, so it will just tell me the content of this file. So you see this file have this, has the content which I have written into this file, right? So let me come out of it. Let me, stop this one also. I just came out of the container. Now I'll see the container I have running here. I'll just delete this container. So for that I have a command called docker rm, and then -f, and then the container ID. And then if you do docker ps, you will see docker container is deleted. Again, I'll do docker image ls. So these are the images I have. So since I have deleted the container, did it delete the volume as well, which we had created? We had created the volume A, right? So let's check that. Did it deleted the volume as well? No, it won't delete. Let's verify that. So if I do delete docker volume ls, so what it will do, you see, this volume is still there, right? So now inside this volume, I have it's mapped to the log folder. It has log folder into it, logs folder, right? In that log folder, we have created a file, container world file. So now we don't have any container here. If you do ps, then you see there's no container here. So since container is deleted, did the data of container is also deleted, which you have written? Let's verify that. So for that, what I'll do, I'll just create another container. Docker, we got into it. So if I do ls, you would see already log folder is there. So inside this log folder, see already a container, whatever the containers file is there, right? So that file we have container one. If you notice, container one has created this file, right? And we are into the container two. So now let me, edit this file. So again, if I do echo here, and I would say container two logs, right? So And then I would like to pipe it or store it into the this file. So I just need to mention like this file name, and if I hit enter, this would write this. This would append this file. I have already told you this double greater than sign would do the append here. So yeah, let me just open this file. So for that I have cat, and then I would do container. So you see the log which was created by container one is already there. It was not removed. It is still there. So see, this is how we do the data persisting. This is how the data persisting thing happened here. Understood? It's just a file thing, right? Similarly, you can mount the database also here, whichever database you want to mount. You want to mount Redis, you want to mount Postgres into it, you want to mount MongoDB on this. You can do all the stuff here. Multiple container can do multiple things. This is how multiple container, can do the, sharing of the data. So again, let me come out of it. Again, I would create another container. Let this container be running. I would say container 3. So it is throwing me an error. I understood what is the error. Already in port 8080, we have container 2 running, so it won't give me a way. I need to find a way. So I'll just change the port. Again, there is a conflict. Some other container is running into this port. So I'll just change the port. I will say 82, then 82. Just give me a moment. Let me create another container, container 4. And I would not, just give me a moment, please. So I just got into it. What did I do? I just removed the 8080 and how this container works. This thing we will discuss in other session, some other session. But let me get into it. So right now I'm in container 4. So if I do ls, sorry, if I do ls here, so I would see logs folder is there. So if I change the directory to logs folder, and if I do ls, I'll be having a container file here. So again, I'll write into this file. I'll say echo, and then I'll say this is container 4 logs, and I would say this is container 4, right? So the moment I do this, and I want to pipe this, I want to only store it into the file. So what is the file name? File I want to store to. So this is the file name. And if I hit enter, you would see this log will be appended to this file. Okay. And then if I do cat, and then if I give this file name, you would see this file container 4 logs. So you see these logs, it is container 4 is also able to append this file. So you remember I told you about the static stuff, right? It's a pretty much same thing, right? This volume A is being shared to these 3 containers. So these 3 container can leverage that volume, and in that volume you can create folders. In that folders you can create any files. So you create your txt file, you create your Excel file, you create your database, whatever excuse me, sorry, uh, storage related stuff you want to do, you can do it by using this, right? So this is how we do the storage. Container shares the data between each other by using the volume, right? So let's move to another topic where we will see like how container can read data from the local system. Local system is the very system where all the happenings of these sessions are happening. So yeah, let's see how we can achieve that. So just give me a moment.